With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is, figure shows the cylindrical tube of volume V with adiabatic walls containing ideal gas. The internal energy of this ideal gas is given by 1.5 nRT. The tube is divided into two equal parts by a fixed diathermic wall. Initially the pressure and the temperature are P1 T1 on the left and P2 T2 on the right. The system is left for sufficient time so that the temperature becomes equal on the two sides. We have to find how much work has been done by the gas on the left part and final pressure on the two sides, that is the left side and the right side. On the third part we have to find the final equilibrium temperature, and finally we have to find how much heat has been flown from the gas to the right of the gas on the left. Okay, so in the given question we have been given a cylindrical tube which is divided by a diathermic wall into two equal volume. Okay, so the initial cylindrical volume was V, so the volume for the left side will be what? V by 2, and for the right side it will be V by 2, correct? Now after dividing, the cylindrical tube is left for some time so that it comes into a thermal equilibrium. Now we have to tell that how much work has been done by the gas on the left part. Okay, since our volume is constant, correct, so the change in the volume will be what? 0. Therefore we can say work is P times delta V. Since our change in the volume is 0, so our work will be 0, correct? Therefore work done in the left side will be how much? 0. Okay, so this is our first part. Now in the second part we have to tell final pressure on the two sides. Okay, to get the final pressure we have to do some calculations. Let us see what calculations we have to do. Okay, first of all, on the left side, let the total number of moles be N1. Okay, so on the left side number of moles is equals to N1, and on the right side total number of moles will be N2, correct? Since our gas is an ideal gas, applying the ideal gas equation we can easily find the total number of moles. On the left side it would come about P1V by 2RT1, and on the right side it will come P2V by 2RT2, correct? So total number of moles given by N will be how much? N1 plus N2, correct? From here we get P1V by 2RT1 plus P2V by 2RT2, correct? Taking V by 2R as common, we get the expression for the total number of moles as V by 2R into P1 T2 plus P2 T1 whole divided by T1 T2, correct? So our total number of moles has been calculated. Now moving further on, the expression for the total internal energy is given as U is equals to 1.5 nRT, correct? And as we know, the internal energy is also equals to NCVT, correct? From here what we can say that CV is equals to 1.5 R, correct? Now internal energy for the left hand side will be what? Will be given by N1 CV T1, and internal energy on the right side will be given by N2 CV T2, correct? So our total internal energy will be what? U1 plus U2, that is internal energy on the left side plus internal energy on the right side, will be equals to N1 CV T1 plus N2 CV T2, correct? Now internal energy is NCVT, so equating it with NCVT, so NCVT will be equals to N1 CV T1 plus N2 CV T2, correct? From here CV will get cut off. Now N1T is equals to N1 T1 plus N2 T2. Since we have calculated the value of N1 and N2, and also we have calculated the value of N, putting it in this equation we can easily find the final temperature or the equilibrium temperature that we get after the thermal equilibrium, and it will come about T1 T2 into P1 plus P2 whole divided by P1 T2 plus P2 T1. Okay, So we have calculated the final temperature, okay, which we have to calculate in the third part. Okay, so this is answer for the third part. Now we have to calculate the final pressure on the left and the right side, correct? Now let us suppose that the final pressure on the left side will be on the left side, final pressure will be what? Represented as P1 dash, and on the right side final pressure is represented as P2 dash, correct? This one is for the second part, that is the B part. Okay, so since the number of moles on the left side will remain same, so applying the ideal gas equation, what we can say is P1B by 2 times T1 will be what? Final pressure, sorry, it will be P1 dash V by 2 times T, correct? Now since we have calculated the value of T, we can easily find the value of final pressure P1 dash. Okay, so P1 dash will be what? P1 upon T1 into T, correct? So substituting the value of T as we have calculated above, we get the value of final pressure on the left side. It will come as P1 T2 into P1 plus P2 whole divided by P1 T2 plus P2 T1. So our final pressure on the left side is this. Now for the right side, similarly we can apply the ideal gas equation. So what will be the equation? That is P2V by 2T2 will be equals to P2 dash V by 2 times T, correct? From here what we can calculate the final pressure on the right hand side, it will come as P2 times T1 into P1 plus P2 whole divided by P1 T2 plus P2 T1. Okay, so this is the final pressure on the right side, correct? Now the fourth part is we have calculated the third part, the equilibrium temperature. Okay, now for the fourth part we have to calculate the heat lost on the right chamber, correct? So the heat lost on the right chamber will be what? Given as N2, sorry, will be given as N2 CVT2 is minus N2 CVT, that is the final temperature, correct? This will be equal to heat lost, correct? Now taking N2 and CV as common, N2 CV as common, what is we get? T2 minus T, correct, is equals to Q lost on the right side, correct? Now substituting the respective value, that is N2 we have calculated, CV we know 1.5 R, and T2 will be T2, and finally T is the equilibrium temperature. So putting the values we get the Q lost, correct? So Q lost will be come out as 3 by 4 P1 P2 V into T2 minus T1 whole divided by P1 T2 plus P2 times T1. Okay, so this is our heat loss on the right hand side. Okay, so our question is complete with this. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.